Welcome to It's Electric. Electricity has had a profound impact on our lives and has truly made it better. Today, we're going to walk you through some of the most basic forms of electricity, including static electricity, current electricity, electromagnetism, and then of course, the applications and uses of electricity. The more we can understand about electricity, how it works, how it's formed, can lead to greater discoveries that can help improve upon our lives and make them that much better. So now, let's get started. Everything around us is made up of tiny little particles called atoms. And those atoms are made up of even smaller parts called protons, neutrons, and electrons. Each one of these pieces has a different charge. For example, protons have a positive charge, neutrons have a neutral charge, and electrons have a negative charge. When you rub two things together, say like my hands, those electrons, which have the negative charge, they might shift from one atom to another. And when this happens, this is called static electricity. Now be mindful, static electricity is not harmful, and you've probably come in contact with a static electric shock more than once in your lifetime. Now this is a static electric generator, and this is a wool pad. So as I put this wool pad here and spin around this barrel, it's making contact with some metal prongs on the inside. And what I'm doing now is rubbing two objects together, and those electrons are shifting from one atom to another, and we are generating static. Now you've probably noticed this at home, say when you are running around in your socks on your carpet and you go to touch something and you get a shock, and that's exactly what this is. So when I put my finger here, ouch, I just got a static electric shock. But you probably also notice that this doesn't happen all the time. So during very humid times, we get less static, but when it's really, really dry, not like today, you might get more static. So static electricity is really important to us, but you're probably more familiar with current electricity. Every time you, say, plug in your phone charger and then connect it to your phone, when your phone starts charging, that's current electricity. So current electricity is when charged particles flow through a conductor and essentially completing a circuit. So this is complete the circuit, and these are brass knobs, and this is a battery here in the center. But nothing's happening, which is frankly not very interesting. But when I put my hand here and put my hand here, the lights turn on. Believe it or not, what's happening is that humans are great conductors of electricity. Now, on the other side of conductors, you also have insulators, and these are things that don't conduct electricity very well. So like the rubber on your shoes is great for keeping electricity out. Because frankly, if I'm out in an electrical storm, I want to make sure that the electricity stays out of my body. So static and current electricity exists because of a fundamental force called electromagnetism. You're probably familiar with magnets, those things that stick to your refrigerator. The other part of this word, electro, hint, that's electricity. So electromagnetism is using electricity to create a magnet. Now here we have a magnetic stirrer, and this was actually invented to stir chemicals in flasks in a lab. So as I turn this on, there's actually a magnet inside, or a piece of metal inside that's encased in plastic so it doesn't begin to break down in the chemicals, but it's allowing you to stir hands-free, and that's because there is electricity running through this plate. So that electricity wakes the magnet up and gets it moving and allows the chemicals to stir. Now you can make an electromagnet at home using copper wire. You'll have to spool it around, say, a nail a number of times, and then you'll have to click one end and the other, say, to a battery. And using that, you could pick up objects that are magnetic around your house. Now, electricity is important to us because we use it for a number of different things, like surfing the internet, driving our cars, but most importantly, using our cell phones. Now, if you could imagine sending a text message that required you to perhaps use a code, something like Morse code, then you can imagine how challenging it might actually be to send a message from one place to another. This is a telegraph, which was, I would like to say, the very first cell phone or text message. So an operator on one side would need to use a key, and the operator on the other side would need to ensure that they were ready to receive a message. Now, there's a battery here, and when I push this button, that clicking noise means the message is being received on the other side. But sending a message isn't so easy as using a keyboard. I would have to memorize dots and dashes in order to send my message, and each one of them represents letters in our alphabet as well as numbers. So as I send a message from here, the operator on the other side would get a printout of dots and dashes, and they then have to decipher that in order to read the message that I sent. Now, this was all done through a battery, a key, and wires that would transfer over telephone poles, sending messages through electricity. And that was the very first text message. As you can see, we use electricity to make our lives easier, and it comes in a number of different forms. However, electricity is not always that simple. Nikola Tesla designed this piece behind me, a Tesla coil, in order to create free electricity for everyone to use. However, the challenge with a Tesla coil is keeping us safe. As you can see, it puts out about 500,000 volts, which means we've got to keep it housed inside of a Faraday cage to keep those volts inside and keep them from hurting you. Free electricity is great, but we really have to think about how we can keep all of us safe from all of those volts.